Okay, so 4-6 notes are on the back side. First thing that I want to talk about is kind of a visual that they have here for us. The process that we're going to learn today or talk about today is completing the square. And as with most math, I mean, we only divide math into Algebra 1, Geometry, Algebra 2, Trigonometry, Calculus. We only do that because it's easier to teach things in little chunks like that. Okay, really math is math, and, you know, it's all linked. It's all the same thing. And so that's kind of what this is showing you. Some people are just visual learners. It might be easier to understand what we're doing if you see the visual as well. Okay? So what we're starting here is with algebra tiles. Anybody ever used algebra tiles in a, maybe elementary school or middle school or anything like that? They're just little plastic blocks that you can put together and make different math problems with them. Okay. Well, that's what we have here, algebra tiles. We have one algebra tile here that is an x by x square. And then this one, the gold one, is b by x. So that means if I wanted to find the area of this entire rectangle, I would have to take x times x plus b. Okay? Length times width, right? So they distribute the x. That's where they got x squared plus bx. Okay? So if we start out with x squared plus bx, we want to transform this into a perfect square. Literally, into a visual perfect square and a perfect square trinomial like we talked about yesterday. So what we do is we break that gold rectangle in half, and we're going to take half of that and move it up top here, up there. That's where that second picture came from. Okay? So now, since I took half of that gold block, notice that the length here is now half of b. It's b divided by 2. Okay? And the length here is half of b. It's b divided by 2. So what we're going to do then is we're going to fill in this part. This is what's called completing the square, okay? So we're going to fill in that missing part in our picture by adding a square. We're going to add a perfect square. And that perfect square is going to be half of b by half of b. Or half of b squared. Okay? And we add that to our equation. So now this is a perfect square trinomial, which can then be factored like we were doing yesterday into a binomial squared. So algebraically it looks like this. Visually, it then looks like this. We're making a perfect square. Okay? Now, again, some people are visual. That may have helped some of you see what's going on. Others might be saying, man, why do you put pictures on this stuff? Okay? But there it is. Regardless of how you learn, that is there for you. Obviously, since this is an Algebra 2 class, we're going to be focusing on the algebra part of this. Okay? So I do want you guys to look a little bit closer at the rule down here on the bottom. They have this rule sitting here that says x squared plus bx plus half of b squared equals x plus half of b quantity squared. What I want you guys to do is to kind of rewrite this. It's going to be kind of small, so kind of squeeze it in there. But I don't want this sitting here, because that's never how it looks when we do our work. It never looks that way. They're never right next to each other. That binomial is always going to be sitting below, right here. And it's going to be x plus half of b, or b divided by 2, and that whole quantity squared. And then over here on the right side of the equal sign is going to be some number that we're working with in our equation. Okay? Now, the reason I wanted you to write it this way is, like I said, that's how we're going to write it in our work. And please pay attention to what we have going on here. Here's our b term in our trinomial, just like it's always been, right? And look what happens. As we go down here into that binomial, this number is half of b. It's b divided by 2. Now look up here. What happens here? We take that number, b divided by 2, and we square it. That's how we're going to work the completing the square. We're going to take half of b, write that number down here. Then we're going to take this number and we're going to square it and write it up here. So we're going to be doing 2 lines of work at the same time. Okay? Let's try an example before we get going too far. Let's try an example. I believe that the first number is number 7. So, taking a look at number 7. In number 7, I can identify this as not being a perfect square trinomial. Because if I look here, I see that x squared, hey, that's a perfect square. But look at our constant term, negative 5. Negative 5 is not a perfect square. So this is not a perfect square trinomial, so therefore I have to make it a perfect square trinomial. So first thing I need to do is I got to get rid of that constant. I'm going to do that by adding 5 to both sides. Okay, so added 5 to both sides. I now write x squared minus 8x. Leave yourself a blank there. Leave yourself some space. Equals 5. So we have x squared minus 8x equals 5. What we want to do is we want to add that constant term that makes the left side a perfect square trinomial. So I'm going to write in there plus something, plus blank. So I'm going to actually add a number there. Well, in algebra, can you just add to one side of the equation? No, you have to do it to both sides. Therefore, the other side also needs a plus blank. All right? Now again, I said we're going to do 2 lines of work at the same time. You're going to want to make sure to write this down. 2 lines of work at the same time. So I'm going to, right below that, go ahead and put a parentheses squared equals. And I know that when my perfect square trinomial gets factored, my first term is going to be an x. I know that already from our experience of factoring and from our experience yesterday factoring perfect square trinomials. Okay, so here is from the rule. The number that goes here is going to be half of our b term. Our b term is negative 8. So what's half of negative 8? Negative 4. So we get minus 4. Well, now the constant that we add here and here is going to be that negative 4 squared. So I'm going to come up here and write negative 4 squared. But what is negative 4 squared? 16. So I'm adding 16. So I'm just going to write 16 on the other side. I'm adding 16 to both sides. Okay? And so now, 5 plus 16, 21. Okay, folks. So again, what did we do? We took half of b. So we took b and divided it by 2. And then we took that value we found and we raised it to the second power. Okay, we squared it. So you guys see how we're doing those 2 lines of work at the same time? Okay? All right, and just so that I can get out of my way of my little scratches I just did there, I'm going to just rewrite it. You guys don't have to rewrite it here. So we now have x minus 4 squared equals 21. Okay, so now it's a process just like we did yesterday. Okay? Now it's a process. We're done completing the square. We've done that part. Now we go ahead and take the square root of both sides. Okay, remember that taking the square root cancels the square, leaves us with x minus 4. And when we take the square root, we get 2 answers. Now, can we reduce the square root of 21? No, because it only factors into 7 and 3. Neither of those are a perfect square, so it stays the square root of 21. We've got to add 4 to both sides. And so we want to write our answer with that constant term, that whole number, first. So our answer is going to be the positive 4 written first. 4 plus and minus the square root of 21. Questions on number 7? Nothing yet? Let's try another example, see if that sparks any questions. Let's look at number 8. So, number 8. Looking at this, I first want to see, well, is it a perfect square trinomial already? And if I look here, I see, hey, I've got a perfect square, that's x squared. Over here, I've got a perfect square, that's 3 squared. But my middle term is not 2 times a times b. It's not 2 times x times 3. Okay, that would be 6x, not 12x. So we do not have a perfect square trinomial. So therefore, our strategy is to complete the square. We've got to get rid of the constant there. We want our constant on the right side. So we're going to subtract 9 from both sides. X squared plus 12x, leave yourself some space because you're saying plus something, equals negative 9 plus that something. Below that, I'm going to write my binomial squared. My first term of the binomial is going to be an x. So, how do I find what goes here? I take that b term, which is 12, take that b term and cut it in half. Well, half of that is a positive 6. Okay, well, now how do I find what goes in our 2 spots here and here? I do what? I'm hearing people whisper it. We take this 6 and we square it. 6 squared. Well, 6 squared is 36, so we're adding 36 to both sides. Okay? Questions on how to find those numbers? No. All right, so what is negative 9 plus 36? 27. So we got to finish solving this guy. We take the square root of both sides. All right, those cancel out. X plus 6 equals positive and negative. Well, wait a minute. Does the square root of 27 simplify? Yes. The square root of 27, yep, 9 is the biggest perfect square. 9 times 3. So that's the square root of 9 times the square root of 3, which is 3. Square root 3. So positive and negative, 3 square root 3. Subtract 6 from both sides. We always want to write our whole number first. So x equals negative 6 plus and minus 3 square root of 3. One last thing to talk about here. You cannot combine the negative 6 and the 3. We do not take negative 6 plus 3, negative 6 minus 3, and have our answers times the square root of 3. Because please remember PEMDAS, your order of operations. Your order of operations says that you have to multiply before you add or subtract. Okay? So if we're going to try to get a decimal approximation, we have to first multiply, then add and subtract. Okay? Since we don't want decimal approximations, this is as far as we can go. Questions on number 8? Okay, then let's go down and take a look at number 9. Taking a look at number 9. Number 9 is mostly set up for us already. I would like you guys to rewrite this slightly, putting in our blanks. So x squared minus 10x plus blank equals negative 11 plus blank. Okay, right below that we put our work of the binomial squared. So it's going to be x plus or minus something quantity squared equals something. All right. What I want you to do with the people around you, you can discuss it with the people around you. I want you to tell me what goes in this blank and this blank and this blank. Okay? So, please discuss it with the people around you. Go. So, what we should be getting is that we took half of negative 10 to get negative 5. And then we take that negative 5 and we square it. We take negative 5 squared. Well, negative 5 squared, a negative times a negative, is a positive 25. What's negative 11 plus 25? 14. All right, so there we are. We have x minus 5 quantity squared equals 14. To solve that, we take the square root of both sides. These go away. We have x minus 5 equals positive and negative square root of 14. Square root of 14 cannot be reduced. We have to add 5 to both sides. Please remember, this 5 is positive. This square root of 14 is both positive and negative. So when we write our answer, the 5 goes first, but just as a 5. It's 5, positive 5. Then plus and minus the square root of 14. Okay? Questions on number 9? Are you sure? Okay, let's take a look at number 10. Number 10 looks different. There's things we have to do first. Okay? So, first things first is that if you look back at any of the problems we've worked, we never had an x on the right side. So therefore, we need to put our x to the left side. So, add x to both sides. So therefore, we have 2x squared plus 12x minus 23 equals 3. Okay, well next, if we're going to complete the square, we got to get rid of that constant, right? So we've got to add 23 to both sides. Okay, so we now have 2x squared plus 12x equals 26. The next thing that I want you to pay attention to is the fact that if you look back at number 9, was there a number other than 1 out in front of x squared? No, it's a 1 out there, right? Well, let's keep looking back. If we look back at number 8 that we did, what's the number out in front of the x squared? We've got a 1 sitting there. If we look back at number 7, what's the number out in front of x squared? A 1. If we look back at the rule, what's the number out in front of the x squared? A 1. To do this, you have to have a 1 out in front of your x squared. So, looking at this problem, what do we need to do?
Factor out 2.
We got to factor out a 2. That's a great way of thinking about it. So we're going to factor out a 2, which leaves us with what inside?
X squared.
X squared plus 6x equals 26. We need to divide by 2. Now, you didn't necessarily have to factor out the 2 first. You could have just taken the 2x squared plus 12x and said you're dividing by 2. But be careful when you do that, because what happens a lot of times is students say that they're going to divide by 2, but then they only cancel out the 2 out in front of the x squared. And they say their answer is x squared plus 12x. It is not x squared plus 12x, because you've got to cancel a 2 out of both of those terms. Okay? So it is safer to factor out the 2. All right, so we now have x squared plus 6x. We're going to add something to that to complete the square, so leave yourself a blank. Equals 13 plus the same blank. Below your work, Write your binomial squared. The first term is an x. So, how do I get that next number there? X plus or minus what? X, is it plus or minus? Plus, because you have a positive 6. Half of 6 is 3, so plus 3. So then how do we know what we're adding to both sides? You square the 3. You take 3 and you square it, which is 9. So we're adding 9 to both sides. So 13 plus 9? 22. All right, so we now want to take the square root of both sides. X plus 3 equals positive and negative square root of 22. Can we reduce the square root of 22? Nope, there's no perfect square that we can factor out of that, so it stays the square root of 22, which we now subtract 3 from both sides. And please remember that negative 3 gets written out in front. So it's negative 3 plus or minus the square root of 22.